Hello, my name is Andre DeWoodian, and today I'll be showing you how to perform partial fractions expansions using MATLAB's residue command. Now, the primary command that we use for the partial fraction expansion is of the form rpk equals residue num den, where num and den are vector representations of the numerator and denominator polynomials respectively. Now, the residue function returns three vectors, as you can see, r, p, and k. The vector p contains the poles of the function, or roots of the denominator. The vector r contains the residues corresponding to each of those poles, or the coefficient that goes into the numerator of the partial fraction corresponding to that pole. Now the vector k contains the direct terms and will only be non-zero if the degree of the numerator is greater than or equal to the degree of the denominator. Basically, if the fraction is improper. Now, in order to perform a partial fraction expansion on, let's say, a given function such as x of s equals 4s squared plus 24s plus 42 over s cubed plus 8s squared plus 25s plus 26, our first step is to define our num and den vectors, which are the coefficients of the numerator and denominator's polynomials. So our num vector in our case will be 4, 24, and 42. Our den vector will be 1, 8, 25, and 26. Now we could just pop those into our residue function, which has the syntax as follows: rpk equals residue num den. And these are our outputs. The r vector contains the residues corresponding to each of these poles. So this residue would correspond to this pole. This residue will correspond to this pole, and lastly, this residue will correspond to this pole. Now the k vector is 0 because in this case the function with the fraction was actually proper, but in the case of an improper fraction where the numerator's degree is actually greater than or equal to the degree of the denominator, this would be a non-zero term. Now what this all boils down to is that the partial fraction expansion is of the form as follows. Now, I've kept all the decimal places just to stay consistent with the outputs of MATLAB, of the residue function. So x of s equals 1 minus 0.5i over s minus negative 3 plus 2i plus 1 plus 0.5i over s minus negative 3 minus 2i plus 2 over s minus negative 2. Now, MATLAB will always break a function out into partial fractions in terms of the complex roots. So in order to simplify this into a form that we can actually work with, the first two terms here can actually be combined by finding a common denominator. And that's something that you could produce pretty simply using MATLAB's symbolic toolbox. So we could define our s, and actually have the first two terms here ready to go. So this gives something something that we can't really work with. So we can use the simplify function to simplify it into a form that's actually workable. So it outputs 2s plus 8 over s squared plus 6s plus 13. Now putting all of this together, our partial fraction expansion becomes x of s equals 2s plus 8 over s squared plus 6s plus 13 plus 2 over s plus 2. So there you have it, how to perform partial fractions expansions using MATLAB's residue command. Thank you.